Hello everyone and welcome to lesson 10.1.3, what if the layers are not the same? Volume of cones and pyramids. So today we're going to be going through a movie theater problem, okay? And when you get to a movie theater and you're about to watch your movie and you say, you know what, I need to stock up on my snacks, and nothing like movie theater popcorn. So today we have a large popcorn and a small popcorn. The question is, which is the better deal? So here we go. You have a choice of purchasing a small or a large serving of popcorn at the movies. A small popcorn comes in a cone and costs $1.50. And a large popcorn comes in a cylinder that costs $3.50. Both containers have the same height and the same bases with the same circular area. Based on their prices, discuss with your team which container of popcorn you think is a better deal. So off to the side right here in your math notebook, I want you to pause the video and write a sentence. Which is a better deal and why? The small is a better deal because. The large is a better deal because. Pause the video now. Okay, so welcome back. We're going to talk about mathematically which is the better deal. Small for $1.50, large for $3.50. First of all, I want to make a comment in 33A. Remember, in terms of their height, they have a matching height. Their diameters are a matching diameter. So problem letter A, I want you to write, the cylinder and cone have a matching height and diameter. This is really important because it's not just any cone and any cylinder. Look, here's a cone and a cylinder with different heights. We need a cone and cylinder with matching diameters and heights. So, problem letter A. The cone and cylinder have matching heights and radius. Problem letter B. How many smalls are the same as a large? That's always the question. How many smalls fit into the large? I want you to write a sentence. I estimate blank number of cones will equal a large. How many scoops will make a large? Pause the video now to make your estimate. All right, welcome back. The question is, how many scoops, right? Because if you buy 2 of these, that'll cost $3. And is that the same? Is it 3? Is it 4? How many of these scoops? So you can't see this, but I have a load of beans here, and I'll do my best not to spill the beans. But here we go. Here is my first scoop. 1 scoop of beans. 2 scoops of beans. And 3 scoops of beans. And you can see it comes right to the top. 3 scoops. Now, some of you know me, and you know that I like to rig the game, right? I don't play a game that I know I can't win. So, here's another one. Matching height, matching diameter. Is it also 3? Well, when I take my cone and I fill it, and I dump, fill, dump. One more. Spilled too many on that last one. Get them all out. Notice, once again, filled to the top. This is a mathematical constant, okay? This cone is 3 times smaller. It takes 3 scoops to make the cylinder. That means 3 times larger, 3 times smaller. The fraction that goes along with this is 1/3. Let's do some writing. Problem letter C. It takes 3 scoops of the cone to equal the cylinder. It takes 3 scoops of the cone to equal the cylinder. Problem letter D. Problem letter D. Now, I'm going to go ahead and scoot this up so that I have a little bit more room to write. For problem letter D, we need to write this. The cone is 1/3. The cone is 1/3 of the cylinder's volume. Okay? The cone is 1/3 of the cylinder's volume. Okay, what does that mean? Well, anytime you are finding the volume of a three-dimensional object, you look at the base. The base is a circle in this cylinder. So to find the cylinder's volume, you do pi r squared because that's a circle. Pi r squared is the circle base. Then I multiply it by the height. Yes, you need to write this down as well. So if you are finding the volume of a cylinder, you are using volume pi times the radius squared times h. But if I know that a cone is 1/3 of its cylinder, this is very similar because the volume of a cone can now be found using this relationship. You know it is 1/3 the size, always and forever, 1/3 the size of the base, which is a circle, pi r squared, times the height. Notice how similar these two formulas are. The only thing that has changed is the fact that a cone is always 1/3 its volume. So let's go ahead and answer the question regarding the movie theater. Okay? Based on the relationship we found in 1033, determine a fair price, what a fair price would be for the cylinder popcorn in problem 1032 if the cone of popcorn costs $1.50. At the advertised prices, which popcorn is the better deal? Here's what I want you to write. It takes 3 small cones to equal the largest volume, period. It takes 3 small cones to equal the largest volume, period. Therefore, it would cost $4.50 instead of $3.50, period. That makes the large a better deal. Now, when they say fair price, what they are saying is you should take $3.50 and divide it by 3 so that they would be equal, and it would be a unit rate. I'm not worried about this because most places also make this a better deal. Like, that's why Costco makes a killing, is because they like big box stores. They like saying, oh, buy the large and get a better deal, right? It's the incentive to buy more. Some of us need to stick to the small and have a little restraint. I struggle with popcorn because it's always so good. Speaking of popcorn, a different movie theater sells popcorn in the container shown below. Notice we have a rectangular pyramid, or excuse me, a square pyramid and a square prism. Not a cube. Square is the base, prism is the shape. This time, the small container is a pyramid priced at $2.50, and the large container is a prism with the same height, same base as the pyramid, and priced at $5.50. At this theater, which popcorn do you think is a better deal? Be prepared to give reasons for your prediction. The question is, do pyramids have the same relationships as cones and cylinders? Cones and cylinders, 1/3. Pyramids and prisms, is it still 1/3? And that's why we're here, is to determine the mathematical relationship. When I take 1 scoop, 2 scoop, 3 scoops. I want you to notice, once again, the relationship is 1/3. Mathematical principle, it's always there. So let's write, once again. Yes, I want the once again because we did cones and cylinders and it happened, and now it's happening again. Once again, it takes 3 small pyramids. Once again, it takes 3 small pyramids to equal the largest volume, period. It takes 3 small pyramids to equal the largest volume. Therefore, it would cost, well, 250 times 3, 25 times 3 is 75, so 250 times 3 is $7.50. So, therefore, it would cost $7.50 instead of $5.50. That makes the large a better deal. That makes the large a better deal. So you have that written down for 1036. Notice the mathematical principle is always there, okay? 1/3 the size. Let's do our final problem of the day. So I want you to notice I have the homework up here, and I also have the last problem and your homework. Notice that those cones are the same. Notice the problems are ever so slightly different. Anne and Dan were trying to find the volume of a cone below. Anne thinks that the cone is 10 inches tall, and Dan thinks that the cone, Anne thinks 8 inches, Dan thinks 10 inches. Write them a note explaining who is correct. Well, I want you to notice when we are finding the volume of a cone, 1/3 pi times the radius times the height. Which of these is the height? Is the height here in the center, or is the height here on the outside? Well, mathematically speaking, height is from the bottom up. Height is from the bottom up. That means that Anne is right. And we need to write off to the side. Anne is correct. 8 is the height. 10 is known as the slant. Okay? The reason why we would need to know the slant is because of surface area. If you were trying to find the surface area of a cone, you need to know the slant height. Okay? We're not doing surface area of cones, we're doing volume. So in this problem, Anne is correct because 8 is the height, 10 is the slant. Now, what you are going to do, I would suggest right now on your homework, is 10-41. To do 10-41, volume equals 1/3 times pi. Now, most people in my classroom are using the pi button, 3.14159265389. That's what happens when you press the pi button. But you could just use 3.14. That would be acceptable. Pi times the radius, 6, squared, times the height, 8. Now, when you put this in your calculator, 1 divided by 3 times. That's one way. You could also type pi times 6 squared times 8 and do it all divided by 3. That's also okay. It's the same mathematical thing. Go ahead and round this to the nearest whole number. That would be acceptable. And it's in inches cubed for the record. Thank you for coming to today's lesson 10.1.3. Dealing with the volumes of cones and pyramids. You need to know the mathematical principle is always 1/3.